class. Today we will discuss on the following objectives. The first objectives would be the different coordinate systems. We have three different types of the coordinate systems. The first one is the Cartesian coordinate system. The second one is the cylindrical coordinate systems, and the third one is the spherical coordinate systems. Thereafter we will define the two different quantities, which are the scalar quantities and the vector quantities. How do we define these two quantities and how do we represent the scalar quantities and the vector quantities? How do we define the unit vectors and how do we define the direction cosines with respect to the Cartesian coordinate system? Let us first define the coordinate systems and how do we select a particular type of the coordinate systems, which are the Cartesian coordinate systems, the cylindrical coordinate systems and the spherical coordinate system. The choice of a coordinate system is generally arbitrary, but in certain situations choosing a particular type of the coordinate systems, which are the Cartesian, cylindrical and the spherical coordinate systems, may be advantageous. These reference systems of the coordinates axis provides us with the unit for measuring the vector magnitudes and to assign the directions in the space. It can be one dimensional, it can be two dimensional, or it can be three dimensional, by which the orientations of the vectors can be determined. The first one is the Cartesian coordinate systems, which is in the forms of x, y and z. Here x represents the x-axis, y represents the y-axis and z represents the z-axis. V is a vector in the three-dimensional space. It is inclined to a certain angle with respect to all the three axes. The three axes are x-axis, y-axis and z-axis. This vector v is inclined at an angle alpha with respect to the x-axis. It is inclined to an angle beta with respect to the y-axis and it is inclined to an angle gamma with respect to the z-axis. Over here I is a unit vectors in the along the x-axis, j is a unit vector along the y-axis and k is a unit vector along the z-axis. The second coordinate system is the cylindrical coordinate system, which is in the forms of r, theta and z. R is a vectors. R is the vector pointing away from the origin. Theta is an angle with respect to the x-axis and z is the distance measured along the z directions. So as in the previous case, in case of the Cartesian coordinate systems, we have the unit vectors in terms of I, j and k. In case of the cylindrical coordinates, we define it as the unit triads. The unit triads are E subscript r, E subscript theta and E subscript z. These are the unit triads or the unit bases in three-dimensional space. The third coordinate systems which we have is the spherical coordinate system, which is in the forms of r, theta and phi, where r is a vector pointing away from the origin. This one is r is a vector which is pointing away from the origin. Theta is an angle with respect to the x-axis and phi is an angle which the vector makes with respect to the z-axis. Similar to the Cartesian coordinate systems as well as the cylindrical coordinate systems, over here we have the three vectors or we define the unit triads in case of the spherical coordinate system. These unit triads are in the forms of E subscript r, E subscript theta and E subscript phi. The two coordinate systems, which are the cylindrical coordinate systems and the spherical coordinate systems, are also known as the curvilinear coordinate system. Scalar. By definition, scalar are the quantities which has only a value, a numerical values, or we can say that it has only magnitudes. The examples of the scalar quantities are the time, density, energy, mass, volume, speed, and so on. The representations of these scalar quantities is by the small letter and the symbol. Vectors. Definitions. Vectors are the quantities which has both magnitudes as well as the direction. When we compare it with that of a scalar quantities which has only magnitude. But in case of the vectors, we define vectors when we have both these quantities, magnitudes as well as the directions, and these vector quantities obeys the parallelogram law of additions as well as the triangular law of additions. The examples of the vector quantities are the velocity, displacements, moment, momentum, and so on. The representations of the vector quantities is by the small bold letters and by the simple. The examples of the vector quantities are, suppose we are interested in finding the resultant of any vectors. We have the two vectors with us, v1 and v2. v1 is this vectors and v2 is this vectors. So whenever we are defining any vectors, the angle is required because these are the quantities, which has magnitudes as well as the directions, and these obeys the parallelogram law of addition as well as the triangular law of additions. So if we are using the first one, which is the parallelogram law of additions, we are interested in finding the resultant of these two quantities v1 and v2. So the angle between these two vectors will be known to us, and by finding out, and if we are interested in finding out the resultant of corresponding to these two vectors, we will simply add quantities v1 and v2 if this angle is known to us. The second one is the triangular law of additions, in which we can find the resultant of the two vectors. V is the resultant of the vectors v1 and v2 by using the triangular law of additions. Representations of the vectors. So the vectors can be represented in the following ways. The first one is when we know the magnitude of the vectors and the angle associated with any of the three axes. If we are working in a two-dimensional space, we require one angle. So in this case, the vectors can be represented by vector v, the magnitudes, as well as multiplied by the cos theta, multiplied by the unit basis in x direction, plus sine theta multiplied by the unit basis in y direction. The second case would be when we know the magnitudes of these vectors and the angles would be defined in terms of the horizontal intercept as well as the vertical intercepts. In that case, we define vectors as v multiplied by the unit vectors along the directions. Unit vectors is a vectors divided by its magnitudes. The third possible ways in which the vectors can be represented, in case of the two-dimensional space, we need the two coordinates, which is the x coordinates and the y coordinates. So say this one is x1, this value 2 is x1, this value 3 is xy1, this value 9 is x2, and this value 6 is y2. If we are interested in defining this vector quantities, we will define it by vector v, the magnitudes, multiplied by the unit vectors along this directions of the magnitudes. Unit vectors. A vector v can be written as v as we define the vector quantities are represented by the bold letters, is equal to v multiplied by the n, where a small v where is the value v is the magnitudes of the vector v, and n is the unit vector with the magnitudes of 1, and the direction coincides with the directions of the v. So we define the unit vectors as vector v divided by its magnitude. Suppose we have a vectors of this forms 2i plus 3j plus 4k, and we are interested in finding the unit vectors corresponding to this vector. So how we will do? We will define the vectors, unit vectors, as vectors divided by its magnitude. So finally we get a vectors of this forms, which is a unit vector corresponding to the vectors we have, which is 2i plus 3j plus 4k. So the vectors in any curvilinear coordinate systems, the curvilinear coordinate systems are the cylindrical coordinate systems as well as the spherical coordinate systems, can be represented as u1 e1, u2 e2, and u3 E3, where E1, E2, and E3 are the unit bases or the unit triads in a three-dimensional space. Direction cosines. Direction cosines are the angle which the vectors makes with respect to the x-axis, y-axis, and z-axis when we are taking the coordinate system as a Cartesian coordinate system. So this one is a unit vectors which is inclined to different angles with respect to the x-axis, y-axis, and z-axis. It is inclined to an angle alpha with respect to the x-axis. It is inclined to an angle beta with respect to the y-axis, and it is inclined to an angle gamma with respect to the z-axis. So in this case, the cos alpha is equal to L, cos beta is equal to M, cos gamma is equal to N. So if we square all these values, we will get a value like L square plus M square plus N square is equal to 1. So this one is a properties associated with the direction cosines in a three-dimensional space. The learning outcomes for this sessions are: we have studied about the different coordinate systems, the Cartesians, the cylindrical, and the spherical coordinate systems. The two coordinate systems, which are the cylindrical coordinate system as well as the spherical coordinate systems, are also known as the curvilinear coordinate systems. Next, we have studied about the scalar quantities. We define scalar quantities with only the magnitudes. It does not require any directions. Vectors are the quantities which has both the quantities, has the magnitudes as well as the directions. Thereafter, we define the unit vectors. How do we define the unit vectors? It is a vector divided by its magnitudes. And thereafter, we studied the direction cosines with respect to the Cartesian coordinate systems, which is the angle which the unit vectors makes with respect to the x-axis, y-axis, and z-axis. This is all about for this session. Meet you in the next section. Thank you.